Hello guys, this is Mr. Lopez, and this is going to be a quick review that goes over your test tomorrow. So while you're looking at the screen, keep in mind this review was not edited, and what I mean by that is what you see on the screen, not everything on here is going to be on the test. I will guide you to what is going to be on the test. This is a review we used last year, so it's a little bit longer. So ignore what you see on your screen now. So let's go ahead and get started. I'm going to try to make this interactive. And what I mean by that is that I want you to try it at home and then compare your answers to what's on the screen. So let's go ahead and without further ado, let's go ahead and get started. So on this right here, you don't have to graph anything like this on the test. But what you do have to know because you're not going to have access to graphing Desmos, but what you do have to know is what's going to happen to the graph. Does it go left? Does it go right? Does it compress? Does it stretch? So before I start, I want to just kind of show some basics up here. So I want you to ignore, I know there's a lot of stuff on the left, but I want you to look at this graph right here. So this is your parent-mother function, the absolute value. This is the original. Notice how the vertex is at 0, 0. I'm going to go over stuff that you should have already learned. Now, if I put a -3 on the inside, so if I do -3, the graph actually moved to the right. Look, watch when I take it off. It goes back to the origin, but look at the vertex. If I do -3, it moves to the right 3 times. If I put +3, it actually moves to the left, not the right. So remember, anything on the inside is a liar. It does the opposite. But now if I put a number on the outside, if I put +3, it goes up 3. That doesn't lie. Only things on the inside are liars. If I put -3, it goes down 3. And what I'm doing is I'm following the vertex. It goes down 3. Remember, you don't have access to Desmos, so you just have to memorize this. So going back to the review, if I look at this number right here, this is telling me that the graph is moving to the right. So remember, anything on the inside is a liar. It doesn't go to the left 4, it's going to shift to the right 4 units. And anything in here has to do with the horizontal. Remember, X is your horizontal, so anything on the inside affects the X, not the Y. So it's horizontal shift. This is how I want you to write it on the test. So let's talk about this one. Let's do the 4 first. I'm going to highlight that in blue. So the way you describe that to get full credit on the test is you're going to say, and I'm going to write it in blue, it has a horizontal shift 4 units, to the right. So basically, it doesn't have to be worded exactly like that, but you got to say something like it translates 4 units to the right. It shifts 4 units to the right. You have to say something like that. Now, this video doesn't lie. This is telling me that the graph is going to go down 6 units. So remember, this number on the outside, I'll do this in red, this is your up or down. So this graph is going to go down 6 units. So say something like, this is a vertical shift 6 units down. And again, you can word it a little bit different, but just say it goes down 6, it goes to the right 4. So now we have one last thing that we have to talk about is this 2 out in front. Now, before I talk about that, I do want to show you how it impacts the graph. So what happens if I have the graph and then I put a 2 in front? So let's see what happens. So let me turn it off and let me put a 2 out in front. So let's see what it does to the graph. Oh. Okay, there we go. So there you go. So notice that the graph, I'm going to turn it off. So with the 2 in front, look what it does. It makes it thinner. So any number outside in the front like that that's being multiplied causes it to stretch vertically. So going back to this problem, this right here affects your vertical. Any number on the outside affects your vertical. So this is a vertical stretch by a factor of 2. It basically makes it more thin. So you have to word it something like this. You want to say it's a keywords that you want to state is vertical stretch by 2, something like that. Those things have to be in your statement. If you leave some of those words out, if you just say stretch by 2, it's going to be wrong. You have to say vertical stretch by a factor of 2. Now, it's not always a stretch. If I changed it to this, if I put a 3 in front like this is a vertical stretch by a factor of 3. Easy, right? So now if I put a 5, that's a vertical stretch by a factor of 5. Now, what if I take that number off and I put a 1/2? It is no longer a stretch, and let's see what it does to the graph. So we're going to come back over here. If I put a fraction between 0 and 1, so like 1/2, look what it did to the graph. Let me change color. I don't like that color. Let's make it red. Okay, there we go. So going back to the graph, so there's the original. I put a 1/2 in the front, and look what it does. It actually compressed it. So it compressed it. So when it's a fraction, just remember that this is on this one, this would be a vertical compression by a factor of 1/2. So basically, if the number is bigger than 1, it is a vertical stretch. If the number is between 0 and 1, like 1/2, 1/3, 1/4, it is going to be a vertical compression. Again, keywords that you want to say vertical compression factor of 1/2. We want to see the words vertical. We want to see the word compression or stretch. So let's try one here off to the side. So if I did this right here, so we'll pause the video. So try one on your own. Let's do this right here. Let's do this, and let's do -10. So pause the video and see if you can list the transformations. Okay, so I'm going to start off with the 6. Anything on the inside is a horizontal something. So this one shifts 6 units. Remember, insiders are liars. It doesn't go 6 to the right. It goes 6 to the left. So we have one transformation here. The 6 represents a horizontal shift 6 units left. Now this number here, that right there, remember what I said earlier, this is your up or down. So this one goes, this is a vertical shift down 10 units. So when you're going to express this on the test, you must use keywords like vertical, shift, down, right? You want to see down, vertical, and then 10 units, something like that. Those are the keywords. Now let's work on the outside. So this right here, that's your stretch or compression. This right here is a vertical stretch by a factor of 3. All right, so let's go back to the review, and let's see, where is it? I lost it. Okay, here we go. So again, you don't have to graph it, just do this real quick. All right, so what I want you to do is try to pause the video if you like, but give me in your head or write them down. What are the transformations for this graph right here? Describe what happens. This one's a little bit different, but it's still good to talk about, so go for it. Okay, so let me start off with one of the transformations you should know already, which is this one here. That's your up or down. So this one has a vertical how have I been saying it? Vertical shift. You can also say vertical. You know, one thing I've been saying is shift. You can also say vertical translation. It's probably what I should have said. It doesn't matter. The key word is vertical translation up to. It goes up 2 units. So there's one transformation. So hopefully you got that one right. What does this negative do? So whenever you have a graph and I put a negative in front, look what it does. It just reflects it over the x-axis. Watch me take off the negative. Put the negative back on. It just reflects. So a negative on the outside causes it to reflect over the x-axis. So there are your 2 transformations. So it's a reflection over x-axis. This number here, this is interesting. This is not on the outside. It's not like this number here. See how that's on the outside? This is on the inside. Remember, insiders are liars. Remember what I said earlier. This is a vertical compression of 1/2. But if I take this 1/2 and I put it on the inside, it changes everything. So it does the opposite because insiders lie. So this number right here, that 2, is it's a vertical, my bad. Remember, everything on the inside is a horizontal. So it's a horizontal stretch by a factor of 2. It does the opposite. Everything on the inside lies. So these are the correct transformations for this one here. So a couple of things to look at, okay? So if I gave you something like this on the test, so let's say I gave you, look at the differences, all right? So let's do a negative first. I put a negative here. This reflection over the x-axis, but if I put it on the inside, it's a reflection over the y-axis. Reflection over the x, reflection over the y. It's kind of weird, I know. Other things you need to know. So if I put a 2 on the outside like this is a vertical stretch by 2, by a factor of 2. But if I do this is a horizontal compression by 1/2. See the difference? This is a vertical stretch by a factor of 2, horizontal compression by 1/2. All right, so now that we've done all that, let's do a practice problem, and then I'll pause the video. So let's do 3x minus 2 plus 25. All right, see if you can list all the transformations. Okay, so I'm not going to write these down, so just listen. This is a horizontal translation. It goes to the right 2, and it goes up 25. So it goes right 2, up 25. This right here is a vertical stretch by a factor of 3. Let's do another one. Go, pause the video. Okay, so this is a reflection over the x-axis. It goes right 6 units. It goes up 5 units. Let's do one that has a vertical stretch or compression. So let's do, if I put a 3 here. Go, pause the video if you like, and then try it. Okay, so this one has a vertical stretch by a factor of 3. It goes left 6 units, and it goes down 8 units, sorry. Now, if I change this like this is now a vertical compression by 1/3, but then if I put the 3 on the 1/3 on the inside, it changes everything. So let's try one like that. So let's do, all right. Pause the video real quick and then see if you can, this one has 3 transformations. See if you know all 3. Okay, so here we go. Let's do the easy one first. This one goes up 6 units. This right here, this is a horizontal compression by 1/4. And don't forget about the negative. That's a reflection over the y-axis. Okay, so those are your transformations. Guys, look up a video. If you want more help, just look up videos. But those are the parts that you have to know for transformation. Let's go back to the review. Here comes the easiest question on the test. One of the questions that I'm going to ask you, let me delete all this stuff, is what is the domain of this graph right here? Guys, if you did the stained glass, that is the easiest question on the test. I don't care how this graph moves. I don't care that it goes down 6, 4 to the right, vertical stretch by 2. Remember, the domain for any absolute value function is all real numbers. That is a domain. It doesn't matter what it is. The domain for this graph is also all real numbers. It doesn't matter what it does. It doesn't matter if it reflects. It doesn't matter if it goes up. It doesn't matter if it goes down. The domain for any absolute value is all real numbers. Okay, moving on. I'm not doing the range because that may not be on the test. Okay, I'm going to come back to this problem here. Let's do some of these solving. All right, when you're solving these, what you want to do first is make sure that this is isolated. The house is by itself. You cannot have any numbers out here or out here. So we're good. This problem is ready to solve. Once you know that this is by itself, you're going to split it into two equations. So we're going to write two equations. You remove the absolute values and you go 2x plus 3 equals positive 15. And you do 2x plus 3 is equal to negative 15. So all you do now is you solve both of these equations. You should get two different answers. So we're going to subtract 3 from both sides. You do have to show work for advanced to get full credit. Divide by 2. So one answer is 6. We solve the other one the same, so we subtract 3. Negative 15 minus 3 is negative 18. Bring down the 2x, divide by 2. You can rewatch the video if I'm going too fast. And then this would be negative 9. So both of your answers are 6 and negative 9. If you want to try this one right here, pause the video. So on this one's a little bit different. Notice that here's the house, here's your absolute value. We have to get rid of this 3 that's on the outside. You can't split it until you get rid of that 3. So we have to get rid of that number right there. So the way we do that is, remember, you do inverse operations. If you're multiplying the 3 to the absolute value, the way you get rid of it is by dividing it. So we divide the 3 into the 24. Now that we've isolated the absolute value, you can split it into two different equations. So we're going to write two equations. We're going to do x minus 5 is equal to 8, and then x minus 5 is equal to negative 8. And then you just solve both equations. U plus 5, boom, boom. You get 13, u plus 5, u plus 5. And then this would be x, sorry, I just got an email. Negative 3. So here are both of your answers. Okay, done. Let's go ahead and do these inequalities right here. It's important that you can solve these because these are on your test. You have to graph the inequality and you have to give the interval notation. Okay, so on this one right here, what you want to do is the same as the others. You want to isolate the absolute value. So you want to make sure this is alone. There's no numbers around it. You're not multiplying or adding anything, so it's ready to solve. So we're going to set up two different equations. We're going to split it now into 3x minus 3 is greater than 15. And then we're going to do 3x minus 3 is less than negative 15. So what we did on the second equation, we flipped the symbol and we changed the sign. And all you do now is you solve both of these. Now, remember, if it is a greater than problem, it's going to have a certain orientation when you graph it. But let's go ahead and solve each one separately. So let's go ahead and we're going to plus 3. We bring this down. And then we divide by 3. And so we get x is greater than 6. So here's part of the solution. We have x is greater than 6. Now, I know that your teacher may have solved this a little bit different in class, but the concept should be the same. So this one here, we're going to plus 3, bring this down, then divide by 3, and there's the other part. So these are the two parts that you got to graph. Now, whenever it's a greater than problem, it's going to be kind of like an Audi where the arrows are going in opposite directions. So I'm going to graph this in blue. So I'm going to graph this part here first. So I go to 6. It's going to be an open circle because it doesn't have the equals to, and it's greater than 6, so I'm going to shade to the outside. Okay. Then I'm going to graph this part right here. So then that would be, you go to -4, open circle, and you shade this. Well, let me use a different color. So then we're going to use an open circle, and it's less than -4, so you shade this way. And there's your answer. So now the way you write, now we're going to do the interval notation. So what you do here is that it's coming from -infinity. Remember, infinities always get parentheses. Now you're going to put -4 parentheses union, and then you do parentheses 6 comma to infinity parentheses. And notice that I put parentheses here because there's no, these circles are open. They're not colored in. All right, so we're going to do the next one. Now this one's a little bit different. This one's tricky. Now the good news about this one is that it's already isolated. So our absolute value is already isolated, so we can split it into two different equations. So here we go. So this is going to be -4x plus 1 is greater than or equal to 9. Now write the second equation. -4x plus 1 is less than or equal to -9. So here we go. I'm going to solve the one on the left first. -1. Now, here's one thing. We're going to have to divide by a -4. Remember, when you divide by a negative number, you have to flip the symbol. So I'm going to divide by a negative number. This one will be on the test. So then we do x is less than or equal to -2. I flipped the symbol because this was negative. So there's one solution. Now let's do the other part of the graph. So let's do -1. And then I'm going to divide this by -4. And now because I'm dividing by -4, you have to flip the symbol. That would be positive 2.5. All right, so let's go. Let's graph it. So I'm going to graph this in blue. Now, on this one, you're doing less than or equal to -2. So you can go this way. I'm going to do it on the bottom because I'm running out of room. So I'm going less than. Okay. Now let's do the other side. We want to do greater than or equal to 2.5. Oh. What happened? Oh. 2.5. It went away. Let's do it again. So it was at -2. And it was this way. Okay. And then this one would be x is greater than or equal to 2.5. So that would be, it's about here somewhere. And then we're going to go this way. And then the interval notation would be -infinity to -2 bracket, because this is equals to. And then there's a break in the graph here, so there's nothing here, so we have to use a union. So we use union, bracket, to parentheses, to positive infinity. Oh, sorry. That should be 2.5, comma, infinity. And there you go. Let's do one more because I feel like we've been doing, I want to do... okay, I'm going to do this one right here. So this is not on, or let's do this one. Let's do 2. Hold on one second. I'm looking for one. Okay, I'll do this one. So let's do... Hold on 1 second, guys. I'm trying to make sure. Okay, I'm just going to make this problem, but I hope it works. Okay, I don't know if this is going to work. Okay. Okay, I hope this works. Okay, so here we go. I had to make this up. Okay, so if you want to pause the video and try this problem, go for it. Okay, so the first thing you want to do is you want to isolate this right here. So we have to get rid of the -2 and the 5. So the way we do that is we're going to plus 2 first. You always want to add or subtract first, not multiply or divide if that's an option. So we're going to bring everything else down. Gives you 30. And now we're going to divide by 5. Oh, and then 30 divided by 5 is just 6. So now that we've isolated the absolute value, we can split it into 2 equations. And then we do 10 minus 2x is less than or equal to -6. So then solve each one. You want to minus 10 first. Now, because I'm going to divide by a negative number, you have to flip the symbol. That gives you +2. And then when I do the second one, divide by -2, we flip the symbol, and there we have our inequalities. It didn't work out like I wanted to, but oh well. So on this one, you're going to put a 2 here. We'll give you the number line, or you should be able to graph it on there. This would be, you're going to go this way to the 2, it's less than, and because it's greater than, you're going to go that way. And then that's how you write that, and this would be -infinity to 2, bracket union, then it would be bracket for the 8, and then this would be infinity. Before I move on, I do want to do, let me do just one. I'm sorry, guys. I'm going to do one more. You can fast forward to the next question if you need to, if you think you got this. But I feel like I just want to do this type of problem because I feel like you need to see it just in case. This is not too different than what we've done. This was actually a problem that was on the problems that I assigned, but I just need you to see it so that you're ready for the test. So this is isolated. So you're ready to split it into 2 equations. And then the other equation would be flip the symbol and then solve each one. So then there would have been -3. This would be -30 or +30 actually. And then because I'm dividing by the -9, you have to flip the symbol. And then so that would then give you, this would be about -3.333 repeating. Let's go ahead and solve this one over here. So you -3, be -9y. This would be negative 36. And you divide by negative 9. You flip the symbol, and that would be 4. So here we have the numbers that we're about to graph. Now, so let's graph this. 4, let's just put 4 here, and then let's put negative 3.33 here. Now on this one, notice how we're shading everything greater than or equal to negative 3.33. So we're going to shade this way. And then on the 4, we're shading less than, so we're shading this way to the left. So because these two are shading in opposite directions, they're going to overlap. So the answer to this one then would be, because if I did it, let me show you. So this one would be closed going this way, right? It goes this way. And then the other one goes this way, right? So one's going to the left, one's going to the right. You want the common region. So when they overlap like that, your answer is going to be basically in between. So it's going to be from here to here. That's going to be your answer. You want what's in between. So ignore these arrows. This right here represents your solution. That right there. That's an overlapping one. That's what I wanted to show you. So then the answer would be bracket negative 3.33 comma to 4 bracket. All right, so let's go to the last problem. Let's see where it is. It's right here. This is your inequality. Sorry it took so long. Okay, so on this one here, Mike, if you want to pause the video to read it real quick, go for it. The first thing you need to do on this problem is we're going to write a system of inequalities. You need to define what your x represents and what your y represents. Your x represents the adult-sized bikes. Your y represents your child-sized bikes. Okay. The shop owner believes he will sell at least 20 bikes, but no more than 40. So he's talking about total. So if he's going to sell at least 40, that means he's going to sell 20 or more, which means one equation that you could do is just going to be x plus y is greater than or equal to 20, because he wants to sell at least 20 or more. But he doesn't want to sell more than 40, which means he wants to sell 40 or less. So then that would be x plus y is less than or equal to 40. He also believes that he will sell at least twice as many adult-sized. So he's going to sell twice as many adult-sized as he is child-sized. So adult-sized is x, right? So he's going to sell twice as many as those. So he wants to sell at least twice as many, which means it's going to be x is greater than or equal to twice as many as child-sized bikes. So that would be 2y. So you have to double the child because he wants to sell twice as many, at least twice as many as those. So this right here then represents your system of equations. Now, we want to make sure that we stay in the first quadrant. We can't sell negative bikes. So we just say we want greater than or equal to 0 because we're not going to sell negative bikes, adult-sized. And we're also not going to get negative answers. So we're going to be greater than or equal to 0. So these are the 5 correct equations that you're going to use. Now, this does not fit on the graph to the right. So you know what, guys? I'm not even going to graph it on here, but just know how to set up the equations. That'll help you on the test. All right, guys, this was just a quick review. I hope this helps. I know I'm going to be available in the morning, the day of the test. Any student that's taking Algebra 2 Advanced is welcome to go to A309. I will be in my room as early as 7:45 in the morning if you need to get tutorials to go over any question that's on the test. All right, guys, good luck to everybody tomorrow, and I'll see you then.